Hi there guys, today I want to make a continue of one of my most popular videos ever made. It was a Minecraft video where I explained some coding using Redpower 2. And if you're anything like me, you always thought Redpower was amazing in Minecraft. How can I use that in the real world? Well, I took the example from the video, and if you haven't seen the video, I will make an annotation, link it up here also in the description, and you can see what's being built there. But one of the things I'm building is a machine in a tutorial that can move a bar from one side to another, just like that, from left to right. And today I'm going to show you how to do that in real life. And I've used Lego to represent my real thing, and what we have here is basically just a DC motor in the back. You can see the wires back here, and I have this bar that is connected to the motor through that wheel. So whenever the motor turns, the bar moves left and right. Of course, it's opposite for you, so my right is your left and my left is your right. And this I'll make work in real life, just like I did it in Minecraft. Well, that's rather simple, but we need to start somewhere. And for this, I could of course use a Arduino and program everything into the microprocessor. And we will do that, but before we do that, I've made a circuit. And this circuit requires only power to work. In the video I showed you a way to move the bar, and if you consider that part of the circuit only, there's a big chip right there. That's a H-brigde that's used to control the movement or the direction of the motor. It sends power through one way, and when you flip it around, it can return power through the same way. So that's amazing. And I hooked it up to these two small buttons right here. So when I click the left one, it should move left. Right one, it should move right. If it's reversed, well, then I just reverse the connectors. In the video, I also showed a blinking mechanism that's blinking the light. I have a passive blinking right here, and this LED is hooked up to 2 transistors and 2 capacitors and 4 resistors. I can't remember the circuit's exact name, but it is used to prove negative voltage. But in any case, it's the simplest way of getting a flashing light. And if you're wondering, I'm using 100 microfarad capacitors, and that will give me a fair light switching. If you want, the time between the lights turns on and off. I'm also going to use this. It's a homemade current limiter, because I usually hook up 9-volt batteries and my circuits require only 5 volts. Excuse me. Anyway, let's hook up everything. The Lego connectors I've made connected a few pins on the end so I can grip them on or click them on pretty fast, just like that. I'm also going to hook up the power, and this is just a demonstration of the entire thing working. I'm going to check that the power is turned off. I'm going to hook up the battery. There we go. And a bit hard. But here we go, I'm turning on the power. And might be hard, but you can see the LED is switching on and off. Let's just let the battery hang down. Right there. So, if I maneuver this around and hold this like this, you should be able to see. So, this is a completely electronic version of the circuit we're going to do. Oops. Yeah. In my video I actually put on a few bars, so I won't be able to drive it too far through the entire thing, but yeah. We're just keeping it like this for now. I'll do a quick close-up so you can see it up close and see what's going on. For that I'm going to move the camera, so hang on. Alright, here we go. This is a bit of a close-up. Let's start from the battery over there. The first thing we have is just a LM7805 to limit our current to 5 volts. Then it's powering into our circuit or prototype board. This part right here, that's the flashing LED part. So if I turn the power on, it starts to flash. This part right here is the the H-brigde, and it's actually called L293D, the chip, and it's a standard H-brigde. And if you notice, we're only using one side of it, so it has a potential we're not using. There we go, and it's hooked up using this wire directly over to the Lego motor. So when I press these buttons, oops, that's too far. You can see there's a instant response. So right now the buttons are opposite, but you can just switch them around as you see fit. About the wiring, I'll post a link to the wiring schematic diagram if you want in the description below, because there's actually quite a bit wiring, but the H-brigde is wired by default, and so is the flashing circuit. I just crammed it into a single piece. Of course, I could have used several and just hooked them up in next to each other, but I felt this was more fitting, so that is why. Next, I'd like to show you how to actually do this a bit more simple, and this is doing it the electrical way. Next up, I'd like to do this with the Arduino, but however I will keep the H-brigde. I'll replace everything else except the H-brigde and the 2 buttons. So let's see how that goes. Okay, here we go. So we have our DC Lego engine right here. It's still hooked up, but instead it's now to this circuit. What it is just a Arduino, and I need to make sure my pins are connected properly, and the camera went out of focus. Let's just fix that before we continue. There we go. Anyway, it's the same circuit as before, kinda. So far all I have done is moved it from this prototype board. Yeah, this one, over to this one, and this one is just a one that's sticked on top of the Arduino. It's not doing anything, it's just there. Right now the H-brigde is connected. I got this LED hooked up to pin number 13 right there on the Arduino, you can see, and it's going through one of the buttons. So the next step is actually to add some code to flash this excuse me, pin. But oh, that's annoying. First I want to try something, because right now it's hooked up to the H-brigde and it should work. So this is the USB power from my computer. I'm just going to hook it in. And you can see there's a red light indicating it's powered on. Well, so let's try this. So yes, it works. Meaning this is hooked up correctly. I still want, if I hide this red LED, this one to flash. So that's one thing we can do in code, and we might even, in order for us to do what we did in the video, I need to upgrade these buttons into something on a computer so I can control this Lego motor with my PC. Next step is some coding, so let's do that. And yeah, coding. Alright, here we go. That's the circuit before we moved everything. This is after we moved to the Arduino. Let's open up the Arduino IDE. And we're just going to use a blank sketch as it's starting with right here. I'm just going to hit save right away and call this one, what should we call it? Lego DC controller. And yeah, we're going to leave these two, we're going to need them later. So the first thing I want to do is let the computer know I'm going to use pin 13. So I'm going to use assign a integer called LED, and it's going to be equal to 13. And we're going to let the computer know we want this pin to be output. Go. And then we need to flash it. So there are several ways to flash a pin using the Arduino. The most simple way is doing this digital write LED high, delay half a second, digital write LED low, delay half a second, save. And I'm just going to disconnect my motor so I only have the small circuit. I'm going to hook the circuit up to, well, before we do that, let's just fix one thing. One of the legs on the shield was outside the actual board, so it wasn't connecting properly, and we don't want that because that could cause a short circuit. Anyway, it reminds me when I'm wearing. Need to put my wonderful bracelet on, my anti-static bracelet. So it's hooked up to the USB. Let's switch, make sure it's Arduino Uno. Yes, it's port 4. This one. There we go. And let's quickly save and upload. This should constantly flash this green LED once it's uploaded. So it's compiling right now. And yeah, should work. I'm actually not sure because I might have flipped the LED the wrong way. Okay, there seems to be a slight problem. because you can see there's a LED switching down there in the corner, but the big one is not. Meaning that is actually not pin 13. Who would know? So let's disconnect this and see what pin it's really hooking up to. So let's see. I see. It's hooking up to a SCL pin. No worries. We can fix that by moving the LED to 13, I believe. Let's see. This one goes in there. These China breadboards don't really fit as they should. But hey, what can you do? They are cheap, dirt cheap. So there we go. It's flashing as it should. Sorry. Very nice. Our H-brigde still works. Let's just confirm by hooking up the DC motor. Oh yeah. So, well, I guess that's step 1 of the program. A flashing LED. This is not a good way of doing it, but it's fine for our setup. Just call the ordinary delay over and over. That's yeah. We're going to leave it as that. The next step is actually to rewire this thing. So I want to take these 2 blue wires that goes to the buttons and simply hook them up to digital pins 1 and 2 instead. So I'm going to do that now. Alright, here we go. As you can see, I have removed the buttons. They used to be right here, and I took the blue wires and put them in digital 2 and 3. So the first thing we want to do is define these 2. So int left, that's Danish, left pin, that's 2. Might be reversed, but then we can change the right pin 3. So in order to use that, just like I did in the video, if you remember, I wrote 2 commands called left and right. I think I called them forward and backward. It was in Redpower they're called words. Here in Arduino we code in C, C#, and we call them functions, just like you would in any object-oriented programming. So I'm going to create one of these voids, and I'm going to call it right. There we go. I'm also going to create one called left. I hope you can see where we're going with this. I'm going to hit save. And first thing we want to do, because we know these need to be grounded, we need to pull them down to activate the H-brigde. We're going to define the pin modes first of all. For left pin output, because it's only going to receive output. Right pin output. There we go. And I'm instantly going to set them I'm going to set them high. So digital right. Oh my god. Left pin high. I'm just going to leave it as that. Right pin high. It means whenever I'm setting them low, it will activate the pin. So whenever I want to turn right, I'm going to digital right right pin low. And the opposite for the left pin. Left pin low. There we go. That should basically be it, but now we need to call the functions. Excuse me. Then again, we also want to turn things off fast, so we're going to introduce a short delay of 50 milliseconds, and then we're going to switch them back to normal. And the same for right. That's just a precaution from my side as a coder. 50 milliseconds is nothing, and as a human you won't even notice it. That's something we talk about when developing gaming controllers. And those 50 milliseconds is something like a reaction time. So next thing we want to do is actually give this some input. We want to input this into our system, because of course in my loop I could just write left and right, but yeah, you know. So I want to write a serial connection to the Arduino, and then we're going to use the normal serial monitor to send commands to our Lego motor. So next thing we want to do is open a serial connection. I think it's like, oh, it's been a long time since I've used that. So 9600, that's fine. And that allows us to use a direct communication between our PC and the Arduino, and that's exactly what we need. So let's see. No, we don't want that in the loop, so that's a good catch. Thank you for that. Let's just set things up a little more organized, because there we go. So we got our setup up there, we got our loop down here, and we got these functions down there, and save. So let's give that a minute. Alright, back to the coding. So we're now going to, well, I'm sorry, I wrote these lines off screen. You can see it's a serial print left and right. It means nothing. It just shows when the serial connection is made to the Arduino. It's going to prompt the user. 1 is left, 2 is right. That's all. So the first thing we want to do is the user, when he presses 1 on the keyboard, the motor should move left. So first of all, we need to define a byte, because we are going to input byte. So we are actually going to call it input byte, and we're going to declare it as an array, because we might have multiple inputs. And we're actually going to write a new function, because this can get rather large, and we don't want large functions up in our main loop. So, well, actually, first of all, let's call one blink. So we take these 4 and move them in there, and we just call blink. There we go. There is a problem. You can see the letters is orange, so let's call them blank instead. We know what it means. Blank. It's still going to blink. Now we're going to write a new function, and this one is going to be called read serial. Just have to make sure it's black so you don't interfere with anything else. We're going to include it up here in our main loop at once. So in reality we just have these 2 functions running over and over. In the read serial, we're actually going to try to read the input from the user. Also ignore anything else we don't know. So first, while serial. This one is actually going to check, is there any serial data available? Did the user input anything at all? Then the next one, I'm going to add a delay just for good measure. I'm going to check if the serial available is actually bigger than 0, in case somebody just pressed space or there was some random unknown error. So we're actually doing 2 checks on the size. Then we're actually going to read what is the input after the checks. And we're going to, it's only going to read 1 byte, meaning it's actually going to read only, well, roughly translated 1 character or 1 number. It's not really that, but it's close. And we're going to store it in a container we called incoming byte, and we're going to store it as a number. So we're going to call parse int, meaning it's going to change the value into a number. And we want that because we're working with numbers. Now that we have the data, the input, we want to do something with it instantly. No, we don't. I am actually wrong. I want to create another function now. So I'm going to create a function called do something. And this do something is going to take an input. It's going to take an input called a int. Let's call it work. It's going to take a number called work. And all it is a switch work, meaning it's actually a statement. Oops, accidentally closed down that program again. Okay, switch work. It's going to take that work and do something with it. It's able to select number 1. If it's number 1, we're going to call the function we called left previously, and left was turning the motor left. And then break. It's important to include this. Case number 2, if the user inputs 2, it's going to call right. Break. Okay, and this entire thing do something we want to call up here. And we're going to input the number we just got from the user. There we go. So, when the user sends a input, it's going to be sent to this function called do something with the user's number. Then it's going to check is it one of these 2. If it's one of these 2, it's going to do one of these 2 functions. Also, it's going to blink while doing all of this. And there's something about these cases. I think you need to include a default action. So, let's do that. Default break, meaning if it's anything else, it's just going to jump out of the loop and go back. So let's save, and let's try and upload this to the Arduino, and there was an error. Colon errors are pretty common, and yeah, they happen. Okay, we have a problem in reading our serial data in line 38. Oh yeah, I'm spelling it wrong. Available. And what's the next problem? It's a numeric content in line 62. Oh. Spelling it again. There we go. And it works. And we're uploading to the Arduino any second. So while we're uploading, why don't I just hook the DC motor up to the Arduino again? Done compiling. Didn't I upload? Shouldn't it say done uploading? I'm uploading again, just in case. You never know. I'm not sure what happened. Okay. Yeah, done uploading. Now the Arduino and the DC motor is connected, and you can see it's blinking. Let's open the serial monitor. Let's try this. Input 1, 2. Nothing works. Nothing works. Oh! It actually works. It's a bit annoying, you have to press enter each time. It works fine. There we go. This is the Minecraft tutorial turned into Lego and real life. And I do believe what's causing the delay. The delay is caused by the light. Because we're running this delay every time it's flashing, you might accidentally click enter during the flash. So that is why we need to work on our flashing abilities. We'll take a look at that in another video. Right now we got everything set up and it's working from our computer. Maybe I should do a tutorial where I take this and build it into Unity, so we can use a game engine to control the DC engine. That could be fun as well. We could add some really nice graphics to the screen, maybe some feedback. Let me know what you think. Comment, rate and subscribe, and I'll see you next time. And if you have any suggestions, please let me know. Thanks for watching. Bye.